I do want to just introduce our speaker, Tina Mathews, who is joining us from Houston, Texas. Tina, I actually would love for you to introduce these fun facts about yourself, and then you can share your screen to start the presentation.
Hi, everyone. So I'm here from Houston, Texas. We have, it's been raining from the morning, so it's been like kind of, wet and gloomy, but hopefully, I can, spread some information and it will sound good. So I like doing a lot of like, catching up on a lot of technology tidbits and sharing knowledge and helping out people in the process. And what I do mainly is conduct certain feasibility research for various technologies and see how it aligns. So I've primarily worked with chip design and optical transceivers, and that's my area. And also evaluating 5G networks. So that's where my networking and device management kind of background comes from. So in my spare time, that's apart from my work and family, I like to catch up on a lot of reading, and classical dance is another passion of mine. I also support and work with the younger generation so that we can teach them about my culture. I'm originally from India, and teach them mainly about their cultures and traditions that are involved, with our upbringing. So let me just go ahead and share. Okay.
Yeah, all yours to get started and share your screen.
So let me just get started. So what are we going to discuss today? So we're mainly going to discuss about IoT and how we present it in the current environment. So basic introduction. We'll try to go through some of the layers, some of the best practices and resources that are available hardware-wise, and in a nutshell, how to set it up. So what's exactly an IoT? Like for somebody from an electrical or computer science background, it's actually a very, common thing. It's called the Internet of Things. But primarily, it's a lot of sensors or embedded sensors that are put together, and they need to communicate with a central computing system, and it could be wired or wireless. And hence, it helps us to monitor a lot of sensors around us. I just put the definition that McKinsey has put. There's a wonderful article that is put by McKinsey about how we can leverage some of the functionalities of IoT and use them for our applications. So it could be like in wearable computing, like in medicine, or it could be just like a smart refrigerator or our air conditioner, where we get to control from our phones, or even in agriculture and in manufacturing. Cars are also pretty much into it. Now, the other one is, of course, industrial and manufacturing, where we look into the safety and the maintenance of various gauges and sensors. Definitely a big play in medical industry, because the quick response time and getting connected remotely helps a lot. Then in smart homes and smart cities, where these kind of ideas have become a reality for a very long time. Now, so just to explain a little bit more, now you would see this kind of a thermostat like in our house, which is pretty common in most of the houses. And the purpose is, of course, to adjust the temperature in the room. So just got a chat in the room. And what we want to do is, like, we want to set the temperature based on our liking. But let's say, like, for example, right now it's raining in Houston, and I might want to make it a little more warmer because I'm wet and cold. So just before I go home, I want to set it, with my app or with my laptop, an app on the laptop, to a higher temperature. So this kind of connectivity the system is made possible through an IoT. So we have a lot of physical devices or sensors that we put together, and these we collect certain data from these devices to an external world. It must be stored in some form of intermediary network or cloud, and the data is processed and given to various application layers where we build apps where these data is available. If you have any questions, please put in the chat. I can always discuss it as we go through so that, it helps us in better understanding. Oops.
No questions just yet.
Okay. So what exactly happens? So what happens is that data is collected. So data is the most important thing over here. We take it, across from devices to the user interface. And we have various devices, which are the physical things of the Internet of Devices. So it might be a sensor or a antenna or a microcontroller. So we have to collate and transfer this valid data into hubs or gateways, and finally, we need to analyze them and use them to make certain, actionable insights. So that is the purpose of it, and of course, the connectivity are how we choose between these places. So for IoT, you can see that there's a lot of variance for it. Like it could be like in the case of an IIoT, like in industrial applications, as I mentioned earlier, like for safety and maintenance, or it could be in medicine. Now, in industrial applications, we can see that we require safety and maintenance. That is the most important thing. So the standards are adhered to that. But in the case of medicine, we need reliability. You don't want to, have a response time which is very slow in the case of medicine. So that standard is more adhered to medical things. And vehicle to everything is right now you have, driverless vehicles. So understanding where these vehicles are is important for us. So that's a little bit of, the introduction and how IoT can actually help us. Now let's understand the various layers and get into a sneak peek of the hardware. So this is again from, the comprehensive IoT platform from McKinsey, and we can see that an infrastructure or a hardware, it will have various compute servers or data storage and networking. The modules are where we would collect all our information. The data storage is where we put things together. And the network is how the connectivity appears. And obviously, we need various development environments, some programming tools to bring up all these kinds of compute servers, a testing environment. Apart from that, once these devices are built, we need to provision them, monitor them, and control all these devices. Then depending on our business or our application, we would need to develop various services about. So it could be actually in the case of analytics where you need to detect a fault or you need to bind certain rules. Or it could be like, if you're trying to capture some pictures, through a camera, some kind of picturing or report creation. And if it's a security service, there should be more importance on authentication, encryption, and kind of fault detection. So let's go through the hardware part of it. That's what we will focus on today, like, how to, build these kind of compute servers and, systems. So in any module, any IoT module, you can find that there'll be a battery module because of course it needs to be powered. Then there should be a sensor, like in the case of a thermostat, it should collect some value from the environment. So it's sensing some active and passive measurements from the environment. Now you can't just keep the data inside the sensor. You need to communicate or you need to put it. And most of these hardware, the batteries, they tend to be lithium based. So we need to check for like power efficiency, form factor, and voltage stability, because most of these modules, they have a small form factor. So the battery should also be small. Um, of course, the question is we can use rechargeable batteries, but then we need to understand like how often we need to replace them. Like a technician or an operator, anybody involved would need to change this IoT module. Like if you're using rechargeable batteries, you need to change them often. So you can't be running up there in like -7 or -8 degrees, trying to change the batteries every month. So you will have to design your modules accordingly. Similarly, the battery life. I mean, you want to give out the power in a very effective way without degrading the battery capacity. So there are various ways we could do it. Like some of the techniques which are very common is, putting the processor in sleep mode, like waking up when it's only required. For example, if it's a medical device, it needs to wake up more often because you need to send data every 20, 30 seconds. Whereas if it's whereas if it's like something else, like an industrial setup, maybe 20 minutes or 30 minutes is okay, because there's people on shift and they need some time to take care of it. The other thing is that, again, when you have to replace batteries, or when you need to look for a backup, you need a battery monitoring system. So most of the applications will have a battery monitoring system. There is always an option of leveraging these um, hardware, like using renewable energy as well. So there are some sensors where they would use solar energy above the ground, or let's say use piezoelectric devices to generate the power. These are mechanisms which are still growing, and they are very effective. So the idea is that you need sustainable solutions, but then again, it's a large amount of fleets, so we have to accordingly see what works. So if you're good with the batteries.
Could you answer a question on the
Yeah.
previous slide?
So I think one of the question is that, if this session is focused on the hardware side, most of the hardware circuitries are specific. Are there some general purpose kit? There are, so I can talk about that later, Larry. Like there are some off the shelf, lot of sensor modules, like not just Arduino and Raspberry Pi, there are some of them, but also like from NXP, from STM, from a lot of chip design companies, because selling them as a module is in fact cheaper for them, unless you want some kind of custom based, you have some custom application that you need to build it for. Yeah. So today we will, focus on the hardware and see how we can put the parts together. I hope that answers your question, Larry.
Do you mind going back? I received another question as a direct message, just to the previous slide. The one that had, do you mind going back? One more? Yeah, so this one, oh no. The next one.
Yeah.
Yes, this slide. So talking about how cloud and AI can be part of the pathway of helping with alerts and requests. Could you elaborate a little bit more on that, just to see how cloud and AI specifically interfaces or relates to this process?
Okay. So, in this case, like for example, like you want to give some sort of backup for the battery with a power supply. So there is a battery monitoring system, and usually they have warnings and alarms. So that kind of warning or alarm is sent to a module, and this kind of module could be like a gateway or could be like a hub that's connected to the cloud. And These connections could be like through MQTT or different ways, cloud APIs that you can talk to. So when it receives a warning, the application layer will tell the user, oh, you know what, you've received a warning regarding this particular node, your battery is dying out. So they may want to switch from battery to the backup power supply so that their operation is still in progress. Um, Now, if they don't want to do it at that time, and when the battery is going to be dead soon, it will definitely send some sort of alarm. So it alerts it to see if I need to go to a backup power supply and request if it needs to do that. It's kind of like a switching mechanism. Does it explain your question?
Yes, I just thought the audience might be
Okay,
curious about that too.
okay. And I think I got a message saying that a lot of the car collision detection now has an alert on star, which is correct, because it needs to preemptively say that, oh, I don't want to get in, I want to avoid this situation. So let's go back. Yeah. So next one is sensors. So as I mentioned earlier, sensors like a thermostat, it needs to take measurements from the environment, and the user needs to give some sort of, response. So most of the sensors, they need analog and digital signals, which need to be fed. Most of them are digitized right now. So to give a quick explanation of what a sensor is, like let's say you walk into like any sort of grocery shop, there are automatic doors. So when you walk close enough, the door will automatically open. So it's more like when you're a kid, it's kind of magic. But the idea is that this module constantly emits some sort of electromagnetic waves, and the waves get reflected back. Accordingly, they know that an object has arrived. So the same kind of things that are used for car, proximity sensors like collisions. Some object is there. When you're on a highway, it should be a car. So when a car comes by, the sensor can detect at what point it is at. So when it's at a certain level, it's just a warning. But when it's too close, it's an alarm and it creates an alert on system. So that is the kind of sensors that are built in. Now we'll just go through like, okay, so we'll just go through quickly like what kind of data is important here. An accelerometer. Can we have any thoughts like, I don't know, in the chat window? Where would you use an accelerometer? Any of them, biomedical sensors, gas sensors, what kind of data is important over here? And in what kind of environment? So in the case of an accelerometer, it's typically like, it's on your camera where you want to tilt it, like make it portrait or landscape. That's where an accelerometer comes into picture. But it is also important in a lot of big devices for safety and maintenance. So it typically is used in like industrial IoTs. Biomedical sensors, just like patient monitoring, that's what is explained over here. Like it could be a heartbeat, your temperature, or your, if you want, like if you're having asthma and your lungs, come up and come down. So some sort of like patient monitoring, adverse monitoring, emergency notification system can be built. Then gas sensors or flow sensors. In this case, it's like to see if there's any particular leakage or anything in a gas, and they will have some chemical sensors to detect certain chemical leaks. And finally, motion sensors. So these are different kinds. There are like lots of sensors that are being used, so these are some of the sensors that could be used. Now, so yes, we've received all the data over here. Now, how do we actually put them out? So once we get, like in this case, there's a temperature sensor, we need to use some sort of MCU or a microcontroller unit. Now, this is an NXP microcontroller unit. So it takes the data from the temperature sensor. So you will need a development environment and some sort of C code or C++ code where you can C++ code where you can actually translate them into actions. So depending on what the sensor gives, like let's say you want to say, oh, you know what, when my temperature is above a certain um, value, I need to convey that information somewhere. So it could, in this particular chip, it uses an RFID. So an RFID, like the tags that you see, it gives the information to the smartphone. But then again, in this case, the range is very less. The application might be very unique. So depending on the application, we might need to choose our MCU with its, required specifications to suit our need. So now, once we have all this data stored inside an MCU, how do we transfer these data? I mean, we have to send it somewhere, right? So in that case, we have to leverage the wireless technology. So in this particular picture, I have a Zigbee module. So this is mainly used in smart houses. Now, the earlier one that I showed, it had NFC. That's where, you can use like an AirTag kind of thing. There are different ways you can leverage it, like MQTT, Wi-Fi, Zigbee, Bluetooth, cellular. These are all ways that you could, leverage the connectivity. But when you choose a connectivity, you will have to decide it based on various things. Like one is the range. How wide kind of an area do you want to cover? Like, do you want to like cover a huge range, or do you want the signal strength to be like very strong so that it's farther off, or even if the signal strength is poor, it's okay. The power consumption, like, are you okay with the battery life being small? Are you okay, like, does it need to be connected 24/7? Because the communication module actually draws a lot of current, so we have to be mindful of that. The bandwidth, do you want to transmit only small amounts of data, or just you know high volume IoT in bursts, IoT data in bursts? So you will have to check like what information needs to be sent on this particular channel. Reliability. Now that's very interesting, because let's say like for crucial deployments like health trackers or medical devices or safety monitors, you would definitely need something that's very reliable, because a small failure can result in a loss of a human life. Whereas if it's something um, uh, like let's say a smart home, it could be just a device kind of malfunction, or um, maintenance that is required, which is still lesser in terms of requirement in the reliability. And finally, the cost. We have to understand that all these modules need to be deployed like maybe tens, thousands units. So obviously we need to consider like what is the cost that the business is putting into. Now, I also want to talk about narrowband IoT, because that's a low range, low power consumption kind of IoT, and that's become extremely popular. It's a standard that's written off cellular, and that's actually focused more towards the IoT kind of applications. Now, the other thing is, yes, I've received all these kind of information from these devices, like it could be smart devices, sensors, industries, machines, and we all convey these kind of wireless messages. But where does it go? It needs to go to some sort of gateway. Now, that's what I think, Hope, earlier you were asking me, like when you go to the cloud or the application server, how does it go? It actually goes through an IoT gateway. So that's like a kind of an embedded computer. It has a lot of storage in it and a lot of processing, much greater than these devices. And this is much more powerful. Like it'll have different protocols and different wireless networks to suit the cloud. In this case, mostly like the competitive market gives us a lot of off-the-shelf gateways. Yeah. So a lot of, like cloud service providers like Azure or AWS or Google Cloud, they might have their preferred hardware gateway that, that they like to talk to. But then, of course, as I mentioned, these are costlier and power hungry than these modules. So when you make an investment into this, you might need to choose it like correctly and with a lot of thought. So I think this message, yeah. So there are different courses that can actually leverage on this too. So I just wanted to talk about quickly, like how we can understand the business and sort of leverage the IoT module accordingly. Like one of the biggest questions is, should we use off the shelf or should we use custom? So how we can make those decisions. Then we also need to evaluate what's available, because a lot of times the off the shelf modules do have you know a lot, they have been tested as a module and they work well. So when you design custom hardware, it's a little more challenging and difficult than buying something off the shelf. So that's pretty much what we could discuss on the hardware side. So I want to now cover what kind of softwares we'll be using on the gateway and also on the application side, to leverage these kind of connectivity. And if there's anything else that you want me to discuss, feel free to share in the chat or to send it out, and accordingly I can fine tune my presentation. Yeah, that's it from me. Any questions?
Uh, I have a couple of questions. I actually would love for you to elaborate a little bit more
Mhm.
on the off-the-shelf IoT modules. And, I imagine, yes, there's a marketplace that exists for this, and maybe some of the decision making around which modules to choose. What do you typically think about, and how would a beginner navigate selecting an IoT module?
So, I think one of the main thing is that, do you have like, do you need to develop and test and maintain all these modules? Now, if you don't have so much of resource to do that, then buying something off the shelf might be better. But if you have applications that are already written and you need to choose, it might be hard to find something straight off the market. So in that case, you need to use either a plug and play solution or you need to customize your modules accordingly. So the other thing is that, like, a lot of data centers and cloud infrastructure is also involved in this. So you might need to read upon like what one particular cloud provider can give, because based on your geographical area too, I know that in Europe and in US there could be differences in what your cloud provider can provide. So you need to check that as well. Similarly, like if you're using a security network, like, some kind of commercial grade authentication and encryption might be required. So you will have to make certain operational and financial decisions based on that.
Yeah, GDPR is particularly a big concern here in Europe. And oh, we have a question in the chat from Larry. Larry's asking, do washing machines really need IoT? And he's posted a link about data transfer that's occurring potentially with washing machines. Um, that's funny.
Well, well, it just, I don't know, maybe yes, maybe no. I mean, for me, the biggest challenge personally is transferring from the washing machine to the dryer. Because you have to still put the load inside the washing machine. You can switching it on only takes like a couple of minutes, but again, you need to look at things that require intelligence. So that's based on how you study the environment. So to be honest, like a lot of these applications are very simple to build, but it's about how specifically it caters to a certain application. Like for example, like it could be like health related things, when people fall, or when how you can use these kind of modules. A lot of the the code and the modules are available online or on JIT, or they are open source, but how you can leverage them is the main thing.
And then in terms of off the shelf versus custom, do you mind elaborating a little bit more on the advantages of one
Okay.
versus the other?
Well, the off the shelf, as I said, like the battery, the MCU and the RF, they're all together. So the good thing is that it's been evaluated, tested as a module. So when somebody sells it, it's going to work. And it might be even cheaper because, they do it like, per thousands or 10,000s. But but then again, it might be not suitable for your application. Like, what if you use it in a high temperature environment? Or what if you need a couple more data that you cannot tweak the software in it to do? So then that's when you need to build custom, kind of modules. But the challenge in custom is, you need the manpower, you need the resource, you need the technological, kind of knowledge to align it and build it. And you might need to go through a couple of iterations. So if time is not at your hands, I think going with something off shelf is better.
We have another question here. I'm in my first year of IoT system study. Can you give some advice to study it well and prepare for future jobs?
Um, well, if you're already into this environment, I think it's very important to understand like how the data is offloaded into the cloud. Because hardware wise, I think yes, having an electrical major will definitely help. But if you're not an electrical major, I think something that's very much in demand is how these APIs and applications can be called, and from these gateways, and the data can be managed. So then again, like there are places where they leverage machine learning and AI to make this data even more useful and understand clusters and sets too. So yeah, those are things that you could probably focus on because that's what right now we are looking into. Because just think about it, like when people build the hardware, they don't want to change it much, but what they want to change is definitely the software.
Um, I was actually going to ask about some good beginner projects, and Larry mentioned one, which is make a small device to water your plants based on the weather.
Mhm.
Um, I've heard of projects like that. Do you have any others in mind, or some that perhaps you've seen in portfolios of beginners, or some that you would suggest?
I think a lot of them are home automation projects, because they're quick and you can test it at home. They are easy to get and there's not much of damage. You don't want to choose something like drones or health monitoring, because health monitoring is fine too, but then you're not sure, right, of the data. So, and drones, of course, you don't want to be flying into your neighbor's backyard. So something small within your house, like controlled doors, open, sound, temperature, humidity, those kind of, make use of those kind of elements. That's a good place to start.
Yeah, Larry's not a fan of circuit design. Are there any more questions before we wrap up? I have one for one more, which is you briefly touched on fleet management. Um, can you elaborate on more on that and how crucial or how important it is?
Sleep management is very important because it's a process in which the device is onboarded to the cloud. So, whenever there's a device that you know is of interest in your IoT application that joins, you need to validate it. You need to make sure that it's secure. You need to make sure that it's joining the network in the right way. So, there is a lot of protocols and handshaking that is involved in it. And again, once the device joins, you need to, either query the device or the device will be sending data. There are also other issues that can come up with like hacking or with the device losing power, what it needs to be do too. So I think in AWS, there's a whole, set of tutorials on fleet management, which is very insightful. They have various tools and, mm, you know, like management systems, which helps to, keep track of all the things that is joining an application.
Pardon me, I didn't realize I was muted. Okay, so I would say that is it, unless there are any further questions.
Mhm.
Thank you so much, Tina. Could you give us a preview of what to expect for part two?
Well, I mainly want to go into like the APIs and how the handshaking is done between the gateway and the cloud, and how because right now there's a lot of focus on pre-native cloud applications, and how those can be leveraged is what I want to sort of look into, and scalability, like scaling these devices like quickly. So those are things that I would like to, look into and talk about. If there's any topics that, can you give an architecture to design it? Uh, that's kind okay.
There's a, there's a
I can actually
did
look at
you
any existing architecture. That's a good thought too. I can look at some existing architecture. Yeah.
I believe that this is in reference to the comment earlier. I want to design I want to design a simple wearable device with additional functions that can access my smartwatch. And the follow-up comment was, can you give an or suggest an architecture to design that? I want to design a simple wearable device with
Mm-hmm.
additional functionality that can access my smartwatch.
Your smartwatch. Hmm. You definitely have to look into like more APIs that can connect to you know you have to see like what kind of cloud network the Apple Watch is connected to, and I think it could be Bluetooth or Wi-Fi. Bluetooth might be an option, because with Bluetooth you can access the device around it, so your wearable device can be identified as a client by the Apple Watch, and the data could be leveraged. So I think the connectivity would be Bluetooth. And I think the best way to start is with like a pulse meter, or, like what else, a temperature meter. So accordingly, we can take it.
All right. Well, there's an interest mentioned in ingestion and messaging queues
Mhm.
for there's an interest in that potentially for part two. I will post what the session will be about, what we end up outlining, or what the takeaways will be for part two. Part two will be next week at the same time. So feel free to reach out in the meantime if there's anything you want us to discuss or include, or if you want Tina to discuss in that talk. But otherwise, thank you very, very much for being here. And for those of you that are building projects, please share the results so we can celebrate your success, and we'll give you some kudos online for doing that. Otherwise, thanks for being here, and we'll see you at the next stop.
Thanks a lot, everyone.